Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices, and our topic is about the measurement and sensors. And here we'll discuss about the classification of errors. So generally we know that no measurement is accurate. Any system cannot be 100% accuracy cannot be obtained in any system. So there would be some error uh, occurring in the system. So we know no measurement is accurate. So there are various reasons why these error is occurring. So one main reason is in measurement, the errors would be due to the parallax error. So parallax error means incorrect citing the measurement. So which means that, for example, in our laboratory, when you are doing the circuit and devices lab, etc., in our electronics lab, so when you are identifying the deflection in our ammeter or any voltmeter, when you are looking at the reading, so we could see if I look straight, my value would be correct. If I look from the sidewards, I could see that deflection is towards the other side. So this is one type of error which is called as parallax error. So which is incorrect citing of the measurement. Second is calibration error. So calibration means if the scale is not accurately drawn. So failure in setting up. So that leads to calibration error. And the other one is zero error. So zero error means if the instrument is not having proper zero, if it is not correctly set to zero, then zero error would occur. And then the next is damage. If the device is damaged or faulty also, there would be the error occurring. So next is a limit of reading of the measurement device. So here it indicates the smallest unit of the measurement of a device. So for example, when I take the ruler, that is the scale which we use. So we can measure from 1 centimeter. So the smallest will be possible 10 mm. So we cannot measure the reading very below the reading which is in our scale. So this is one example of limit of reading of the measurement device. So limit of reading means, as discussed, it is the smallest unit of measurement on a measuring instrument. So in a laboratory, when we are performing various experiments like PN junction diode characteristics, we go for using ammeter and voltmeter at specific range. We generally prefer microamps range, which means that it can read minute values of current. When I choose ampere range, I am not be able to measure the reading, which is deflection occurs only in microampere range. So that is one example for limit of reading. Then the greatest possible error, it is the absolute error, which is equal to half the limit of reading. And the upper and lower limits are the smallest and largest value between which a measurement can lie. That is the upper and lower limit. So we can classify errors into three major types. One is random error, the other one is gross, and the third one is our systematic error. So gross error would occur due to the human error, and systematic error would be due to the instruments and observation, and the random error would be due to the environmental factors. So now let us discuss in detail about these three types of error. So firstly, talking about gross error. So as I told, it occurs due to human mistake. So when your parallax error is a gross error. So when we are recording or calculating the measurement, this type of error occurs. So instead of reading the temperature as 31.5, we might look at and read as 21.5. That is the human error. And it is very tough to calculate mathematically. Mathematical analysis cannot be done for the gross error. So we can avoid these type of error by taking great care in reading and recording the data. And another thing is we can take 2 or 3 consecutive readings and we can take the average for the better quality measurement. So next is systematic errors. So systematic errors is classified into 3 categories: instrumental error, environmental error, and observational errors. Instrumental error is something which arises due to the problem in the instrument. Any fault or defect in the instrument would cause instrumental error. As an example, if I take a spring which is used in the permanent magnet, if it is weak, then it will read high. So there would be the various reason like friction, hysteresis, etc. And due to the misuse of instrument, if the user does not know the proper usage of instrument, also such type of error would occur. And also the loading effect also causes these type of error. Environmental error. So as I told, various environmental factors like humidity, dust, vibration and other external magnetic or electric field will cause the environmental error in the reading in the instrument. Observational error, it was already discussed, which is called parallax error, and that would give the wrong estimated value, incorrect conversion of units, manual calculation applying wrong formulas. All these things comes under the observational errors. So this is the relation between the instrument reading and the actual reading. When error occurs, how the slope is. We could see that here we have a offset error. So offset error means which is indicating a shift from the reference point to the especially in y-axis. So that is called offset error. And random error, it is we cannot find out the exact reason. It just happens as such. So we would be unaware of such type of error which is causing, and this is also called as residual errors. So today's assessment identify the cause and example of gross error in measurement. So gross error, as discussed, misreading, incorrect instrument setup and computational errors, formulas and applying formulas. All these are the causes for gross error. For example, as I told, in a scale, if we are looking due to poor eyesight, we might take wrong reading. Calibrating the proper zero setup will also lead to these types of error. Thank you.